Now let me talk about constraints. So what are the constraints? One table has many attributes or columns, and each column may have some additional constraints. And if you implement those constraints in your database software, it will automatically control those constraints without any manual interruption. Let's start with the most important constraint called Entity Integrity Rule. So what is Entity Integrity Rule? Simply, in one table, we must have a primary key. That's in the Entity Integrity Rule. So using this primary key, each row in your table can be uniquely identified. For example, if we have a vendor table, what would be the primary key? Vendor code is primary key. If it's a product table, what would be the primary key? Product code would be primary key. So you need to define primary key. That's Entity Integrity Rule or primary key constraints. Good. Next one is called Referential Integrity Rule or FK constraint. So Referential Integrity Rule says if you have a database and when you have a table that's related with another table, you will have a foreign key. And using this foreign key, you can reference the other table. And how you can reference, for example, in the previous example with the product table's vendor code is referencing vendor tables. Again, you can specify a column for this table as well. So vendor tables, we code columns. So by specifying this, you cannot enter any value that does not exist. For example, let's say there is a vendor 1 and a vendor 2. In the product table, we have a P1, P2, P3. When you specify which vendor is providing this product, you can say V1 and V1. And let's say you by mistake enter V3. Is it allowed? No. Why? Because in vendor table, we have only 2 vendors. But if you try to enter V3, your database will automatically create the error message. Hey, you are trying to enter V3, but when we look at vendor table, there is no vendor like V3. So it must be error and you need to fix it. So by adding this kind of constraints, we can check for every foreign key, there is a corresponding primary key. So using this example, you may better understand what this statement says. In addition to primary key constraint and foreign key constraints, there are some popular constraints you can use. The first one is non-null constraints. Non-null constraint ensures that column does not accept nulls. So in your ER model, when there is an entity, we have attributes. So let's say attribute 1, attribute 2. For each attribute, using boldface or not, we can describe whether this attribute is required or optional. If it's required in your database, you must say it's not null. By adding these constraints, actually, when you try to leave this column, leave this attribute's value as a null, it will automatically prevent it. So for example, let's say there is a vendor table, and let's say vendor's first name. We don't want to make it as a null value. Then you can add this constraint, non-null constraint, after the column name and the data type. I'm going to show you an example shortly. How about unique constraint? Unique constraint ensures that all values in columns are unique. Let me give you the example with the vendor table one more time. In the vendor table, we have a vendor code. And the vendor code is primary key. Then, without adding this unique constraint, automatically we know that V code cannot be duplicate value, cannot have any duplicate values. It must be unique, right? But in addition to this primary key, suppose we have vendors, how about social security number? Then this is not primary key, but we want to prevent any errors of entering duplicate social security numbers for different vendors. How can we prevent it? by adding this kind of constraints. So by adding unique constraints, we can prevent any potential mistakes or errors of entering duplicate values for one specific column. Good? Default constraints. Default constraint is also useful. Default constraint assigns value to attribute, or in this case column, for your create table statements when a new row is added to the table. For example, let's say there is a customer table, and one of a customer table's column is, let's say, phone area code. And you are using this system, let's say, in Salisbury. And most of customers, their area code is all 410. Then when you try to enter new customer, instead of entering this 410 manually, can we just automatically add this 410 by default? Yes, you can do that. That's how to use default constraints. I will show you one example shortly. Good? So let's move on. So I want to show you this product table statements one more time. Now you may better understand. In addition to the structure of create table statements, let's look at some key constraints. So again, we start with the create table keyword and the table name, and we are defining this table inside this parenthesis. And we list up those columns, and each column we have data type, right? And in addition to this data type, after space, we add some constraints. Now you may better understand non-null and unique constraints, what this means. And also you understand the default. So for the price, when no value is entered, instead of just leave this value as null, we want to add 0.00 as a default value. Same for discount. And also in this case, actually I added this primary key for P code. So for P code, we already have this constraint primary key, and actually it's not necessary to have this non-null and unique. So actually it's redundant. So it will give you some warning message, and it's okay to leave them as is, but if you have a primary key, actually you don't have to add non-null, because the primary key also already include this non-null, and the primary key must be unique, so we don't have to actually add these constraints. So adding primary key would be sufficient for P code, because non-null and unique is part of this primary key constraints. Does it make sense? Good. Yes, actually I explained most of them. So in this, just focus on what are the constraints you can add for each column. That include the non-null and default and the unique constraints. Okay, so as the last example of data definition language, let me just briefly talk about drop and alter table statements. After you design your tables, so after you run your logical design, and after you create actual tables in the database, sometimes your initial design need to be modified. How can we do that? You can completely drop your existing table, and you can rerun create table statements. For this, you need to drop table, then use this drop table statements. It's similar to create table, so drop table keyword then followed by table names. So for example, if you want to drop vendor table, you can say drop table vendor. The other approach is, instead of completely drop your existing table, you can change existing table structure. So in that case, actually you are altering existing table structure. So use the keyword alter table followed by table name and some commands. So for example, you forgot, let's say, to add primary key for one table. Then can you add it later? Yes. For example, alter table, table name, and you can just use add statements, add primary key and the column name. Then you can add the primary key in the existing table. There are some more commands associated with this altering table statements. Okay, so that's all about DDL. So I explained the concepts of logical design, and particularly in this topic, we focus on data definition languages that include create table statements, drop and alter table statements. Now in the following video, using this anti-relationship diagram as an input, we will create actual tables. So we are going to write down actual create table statements. In that hands-on exercise, you can confirm whether you understand the concept of logical modeling.